Agencies are making plans to catch space rocks from other solar systems. Billy Bryan and Christopher Carter from The Conversation report, in late 2017, a mysterious object tore through our solar system at breakneck speed. Astronomers scrambled to observe the fast-moving body using the world's most powerful telescopes. It was found to be 1/4 mile, that's 400 meters long, and very elongated, perhaps 100 times as long as it was wide. And researchers named it Oumuamua, Hawaiian for scout. Oumuamua was later confirmed to be the first object from another star known to have visited our solar system, and it was an interstellar comet, that is. And while these interstellar objects ISO originate around a star, they end up as cosmic nomads wandering through space. They are essentially planetary shrapnel, having been blasted out of their parent star systems by catastrophic events such as gigantic collisions between planetary objects. Astronomers say that Oumuamua could have been traveling through the Milky Way for hundreds of millions of years before it encountered with our solar system. Just 2 years after the unexpected visit, a second ISO, the Borisov comet, was spotted, this time by an amateur astronomer in Crimea. And these celestial interlopers have given us tantalizing glimpses of material from far beyond our solar system, but what if we could do more than just watch them fly by? Studying ISOs up close would offer scientists a rare opportunity to learn more about far-off solar systems, the star systems, which are too distant to send missions to. There may be over 10 septillion, or 10 with 24 zeros, ISOs in the Milky Way alone, but if there are so many of them, then why have we only seen 2? Put simply, we cannot accurately predict when they will arrive. Large ISOs like Oumuamua that are more easily detected do not seem to visit the solar system very often, and they travel incredibly fast. Ground and space-based telescopes struggle to respond quickly to incoming ISOs, meaning that we are mostly looking at them after they pass through our cosmic neighborhood. However, innovative space missions could get us closer to objects like Oumuamua by using breakthroughs in artificial intelligence, AI, to guide spacecraft safely to future visitors. And getting closer means we can get a better understanding of their composition, geology, and activity, gaining insights into the conditions around other stars. Emerging technologies being used to approach space debris could help to approach other unpredictable objects, transforming these fleeting encounters into profound scientific opportunities. So how do we get close? Speeding past Earth at an average of 32.14 kilometers per hour, ISOs give us less than a year for our spacecraft to try and intercept them after detection. Catching up is not impossible. For example, it could be done via gravitational slingshot maneuvers. However, it's difficult, costly, and would take years to execute. The good news is that the first wave of ISO hunting missions is already in motion. NASA's mission concept is called Bridge, and the European Space Agency, ESA, has a mission called Comet Interceptor. And once an incoming ISO is identified, Bridge would depart Earth to intercept it. However, launching from Earth currently requires a 30-day launch window after detection, which could cost valuable time. Comet Interceptor is scheduled for launch in 2029 and comprises of a larger spacecraft and 2 smaller robotic probes. Once launched, it would lie in wait 1 million miles from Earth, waiting to ambush a long-period comet, slower comets that come from farther away, or potentially an ISO. And placing spacecraft in the storage orbit allows for rapid deployment when the suitable ISO is detected and the time comes to capture it. Another proposal from the Institute for Interstellar Studies Project Lyra assessed the feasibility of chasing down Oumuamua, which has already sped far beyond Neptune's orbit. They found that it would be possible to, in theory, catch up with the object, but that this would also be very technically challenging. The Fast and the Curious. These missions are a start, but as described, their biggest limitation is speed. To chase down ISOs like Oumuamua will need to move a lot faster and think smarter. Future missions may rely on cutting-edge AI and related fields such as deep learning, which seeks to emulate the decision-making power of the human brain to identify and respond to incoming objects in real time. Researchers are already testing small spacecraft that operate in coordination swarms, allowing them to image targets from multiple angles and adapt mid-flight. At the Vera Rubin Observatory in Chile, a 10-year survey of the night sky is due to begin soon. This astronomical survey is expected to find dozens of ISOs each year. Simulations suggest that we may be on the cusp of a detection boom. Any spacecraft would need to reach high speeds once an object is spotted and ensure that the energy source does not degrade, potentially after years waiting in storage orbit. A number of missions have already utilized a form of propulsion called the solar sail. And these use sunlight on the lightweight, reflective sail to push the spacecraft through space, and this would dispense with the need for heavy fuel tanks. The next generation of solar sail spacecraft could use lasers on the sails to reach even higher speeds, which would offer a nimble and low-cost solution compared to other futuristic fuels such as nuclear propulsion. A spacecraft approaching an ISO will also need to withstand high temperatures, as possibly erosion from the dust being ejected from the outside as it moves, while traditional shielding materials can protect the spacecraft. They add weight, though, and may slow them down. To address this, researchers are exploring novel technologies for lightweight, more durable, resistant material, such as advanced carbon fibers. Some could even be 3D printed. They're also looking at innovations using traditional materials such as cork and ceramics. A suit of different approaches is needed that involve ground-based telescopes and space-based telescopes, and working together to anticipate, chase down, and observe ISOs. New technology could allow the spacecraft itself to identify and predict the trajectories of incoming objects. However, potential cuts to space science in the U.S., including to observatories like the James Webb Space Telescope, threaten such progress. Emerging technologies must be embraced to make an approach and rendezvous with the ISO as a real possibility. Otherwise, we will be left scrambling, taking pictures from afar as yet another cosmic wanderer speeds by. This is from the conversation on Science Alert. It's by Billy Bryan, research leader, RAND Europe, Chris Carter, analyst, science and engineering technology, team, RAND Europe, and Thodera Ogden, senior analyst, defense and security team, RAND Europe. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.